Hello and welcome. This is Juan Azori from SPINBIT Corporation, and today I would like to introduce our process automation suite. SPINPAS, for short, is a distributed processing platform or middleware conceived with the idea of being able to implement any business process and withstand any amount of volume. The cornerstone of SPINPAS is its messaging system. Messages are used to pass data to other processes or to trigger actions by schedulers. An added bonus is the ability to queue files of any size as an alternative means of inter-process data exchange. A distributed system is composed of many running parts which SPINPAS controls through process monitors. So how useful is SPINPAS? A whole lot, I would say. It is the infrastructure software to build pretty much any business process, integrate applications, or redefine process interfaces. A good analogy would be to think of it as a cluster of application servers, but with the freedom to use any programming language to implement individual processes. Let's take a look at the core of SPINPAS, its messaging system. There are both database messaging utilities and file-based utilities. The database messaging programs are putMessage, listMessage, and getMessage. Since their queue reside on a database, the only requirement to create a cluster of processing nodes is network access. Let's see them in action. To place a message on the user's default queue, just type putMessage plus the message. To see what messages are on the user's default queue, type listMessage. To retrieve the message, type getMessage. Of course, we can place messages on different queues. To that end, use the -q option, like so. Looks pretty simple, huh? I agree, but don't underestimate the power of messaging. Any node with access to the queues can process messages, so a cluster processing power grows tremendously by adding nodes distributed across the network. Let's see an example. Let's say I would like to get quotes for the symbols stored in this symbol file. I'll have two processes working off the default queue. It will continuously get a symbol from the queue and call empty_getData, a utility from the SPINMG suite, to request a quote. As you can see, the load has been shared between the two running processes. GetMessage retrieves one entry at a time. To retrieve multiple entries, use the -n option like this. You can also retrieve messages based on regular expressions, like so. When designing business processes, please note that there are two basic processing modes, asynchronous and synchronous. The example we just saw uses the asynchronous mode since the process creating the request does not expect a response. In synchronous mode, the process creating the request will wait until a response is received. There is a special feature of getMessage designed to help implement synchronous mode, the -t option. T stands for until or to specific message is received. Let's see an example. Let's put the contents of the symbol file on the queue again and add the message done. Using the -t option, we can now retrieve all messages until done is found. To illustrate synchronous processing mode, let's review this example. The lower script will put a message composed of a symbol, a number, and an output queue into the default queue. It will then read from the output queue until the message ACT is received. The upper script will read a message from the default queue, parse it into fields, and then call the empty_getData utility specifying the output queue and the -k option to write an acknowledgement message. So basically, we put a request message into the default queue and wait for the data in the output queue. Voila! So synchronous messaging is the natural processing mode for creating service-oriented architectures. The file-based messaging utilities perform similar functions as their database counterpart, but use files as queues instead. Let's use the previous quote example by using file messaging to illustrate. File-based messaging utilities are very handy for writing adapters during application integration projects, as most programs' output and logs are written to files. Notice that in order to create clusters using file messaging utilities, they should be shared across nodes using NFS. Queuing messages for inter-process communication is very efficient, but when large amounts of data needs to be exchanged, queuing files is a better choice. Let's see an example. Let's use putFile to put the following file into the default file queue. Notice we are not putting the contents of the file into a messaging queue, but the actual file into a file queue. One of the powerful features of file queue utilities is the ability to send and receive full directory structures, like this. There is no limit on the file size to be uploaded. Use the list file -L option to see file attributes. Use getFile to get one file at a time, or the -N option to get a whole bunch at once. Use the -P option to preserve attributes, including path. Powerful, right? Let's conclude this first part with an example that combines messaging and file queuing. A user will request a stock chart. She will put a request message in the default queue. The server will parse the message and get the data and output to a file queue. A second process will retrieve the data file, create the chart, and put the output into the default file queue. So let's review the code. On the lower terminal, we put a message and wait for the output file to feed Firefox. On the left terminal, we have created a script to parse the message, get the data file, and output to a temporary file queue. We pass the message as an argument to this script. Finally, on the right terminal, we have created a script to build the chart and put the output file into the default file queue. We pass the stocks data file as an argument to this script in the loop. Since we're running in debug mode, we will see the scripts executing on each queue. Let's fire it. We hope you enjoyed this short video. The next video will demonstrate SPINPAS data management utilities, job schedulers, and process monitors. As usual, please send us your comments at info@spin-bit.com. Thank you.